introducing you both, and then I'll ask you to start presenting.
Okay.
Okay, sir.
Right. Thank you.
So, good morning, all the students, and today's guest, and in association with IIIT Hyderabad Virtual Labs is Mr. P. Ravi Shankar, the program manager. Is currently working as a program manager in IIIT Hyderabad Virtual Labs. He is responsible for outreach of virtual labs in Andhra Pradesh and Telangana states, and also hiring the people, establishing the business processes and HR activities, and some kind of supporting in the internship programs, and also helped in developing of a digital classroom building structure. He has a vast experience throughout his career of 43 years. Out of this, 17 years is being worked for the IT industry, and 21 years he worked for manufacturing in industry. About 4 years he is working with IIIT Hyderabad Virtual Labs under MHRD's initiative. So basically, he is a mechanical engineer in postgraduate and has completed his degree from IIT Madras. So it's not only for taking care about this, but also he has initiated with many number of business development models like Samrat Way and Koth IT with the newly introduced freshers, and as well for new recruitment of the people for student community. So he is also developed a skill connect program for IEEE Hyderabad, and it is an online version where it is enable to the college students to learn and become able to deliver and end-to-end applications while in college. So I just briefly introduced Mr. P. Ravishankar, and who is going to work for, who is going to show us with enormous experience what he is having with us on virtual labs. Another comment of Mr. P. Ravishankar, who is also working with the IIIT Hyderabad as intern, who is Mr. Shashank Ramachandra. He is a passionate building about business and how the people come together to build businesses. And he is an avid watcher of a Shark Tank and economic enthusiast. He is deeply interested in valuation decision or variations in and supply demand continuums. He participates in learning while builds his music band as a regular feature in Hyderabad cultural scene, World Music Day, and open mics. As aspiring entrepreneur, he is mentored by industry veterans like Mr. Ravi Shankar, past IEEE chair, on various aspects of technology, entrepreneurships, and business during these inclement conditions created by the pandemic situation of COVID-19. His deep interest in virtual labs and shares his experience in the use of virtual experiments. He brings from the student perspective and experience with doing the virtual experiments by virtual labs, which are developed all the prestigious institutions of IITs, NIT, and IIIT, and MIT like universities. So thank you for accepting our invitation, sir, and for joining us with enlightening the freshers engineering students on virtual labs, so that how that would really help the students to make simulation and to understand what background process of every program is going to work. Thank you, sir. Thank you for joining us. Please start your session, sir.
Thank you, Dr. Varaprasad, and good morning to all the participants, students, faculty, and everybody, and parents, and all those who are present. It's really a great opportunity for me to be talking about and such an important topic as a virtual laboratory because it forms one of the very important methods through which people can learn. So I will essentially share my screen right now and then we will run through the presentation. But basically, that's only a background support. And I will try to tell you how you can benefit from this and how others have benefited from this program. Um, just give me a minute to share the screen. Yeah, so sorry about this. Yeah. Are you able to see my screen? Are you able to see my screen?
Yes, sir. Yes, sir.
Yeah, okay. So virtual labs, this is basically all experiments that students do, about 1700 experiments that students do in colleges, which includes all the 11 domains that are known. That means all the departments, as we call them in colleges, electrical, mechanical, civil, and so on. There are about 11 different departments. Then there is physics and chemistry. And there's a little bit about communication, English, etc. So these 1700 virtual labs are available to you free of cost. And all you need is just a browser and maybe some small updates here and there in software. Um, Otherwise, it's totally usable from anywhere, anytime, any experiment, as long as you want. You can use it through your laptop, through your desktop, through your mobile phone, through your iPads, or any other devices that you have. So virtual labs, that way, it's like the lab is with you all the time. Now, experiments really are very important tools. Probably they are as important, or maybe even I would say many of the experiments are more important than learning the theory part because the application of whatever concepts you learn and the relevance that they have with real life work are highlighted or they are focused on, and you actually do things with your hands to understand your concept. See, no concept is understood very well unless you actually use it, apply it, you grind it up and internalize it. Until you internalize it, for example, your multiplication tables, which you learned when you were probably in early school, most of us have memorized it. And because we memorize, we know 2 into 2 is 4, and we know 10 into 10 is 100. I mean, I just chose very simple ones, but 11 into 11 is what? Say, if it is 121, it is there. It just comes to you without even you're thinking about it. It is automatic for you. It's as automatic as breathing. So if it has to become that good, then unless you apply, unless you understand, unless you look at, try to repeat the concept in your mind multiple times and see how it is related to so many other things around you, it won't stay with you. See, knowledge is like thin air. It just goes. It doesn't stay with you unless you capture it and put it in some section of your mind and keep it there and then know how to draw and when to draw. So this is what I'm calling as internalization. And in a way, expertise is also this. Somebody has done it so many times, somebody has understood it so well. He may have taken, some experts may have taken only once or one or two repetitions, whereas there will be people who may have taken 100 repetitions on a certain concept. It is because of that repeated attention that they have paid and they have internalized, it has become part of them, and therefore it is staying with them all through. Your mother will never make a mistake in putting salt in some dish. She doesn't measure using a spoon, or she doesn't refer to YouTube and see how many spoons are put. Her fingers and her eyes know, and she will pick up the right amount. So this is a perfect example of what I mean by internalization. And unless you internalize anything that you learn, it won't stay with you. Please remember, in Telugu, I don't know how many people know, mukku మీద పెట్టుకుని రాస్తామని, that is, before the exams, we mug it up and spill it out in the exam and come back. After that, it won't stay with us. So Virtual labs or experiments are very relevant from that perspective because they force you to apply. They force you to apply concepts that you learn, and therefore they're very, very important. So this is basically, and that is why making so many labs available. See, in a normal traditional classroom kind of or a lab experiment, you go to a lab and do. You have a limited amount of time. Then in that limited amount of time, there are probably batches who are doing it, or maybe if there is an equipment is big, it's very hard for you to get time to be there, and there's a lab assistant and there are different resources like some sample piece on which you're going to do your experiment. All these are very limited, so your ability to understand, your ability to kind of play around with the idea and absorb it is very, very poor. So you are kind of constrained there. But in a virtual lab, once you know that some experiment is there, you come back and look at your virtual lab here. You can repeat it any number of times. In the simulation, you can make changes to your parameters and say if this was this much, if this was that much, if this parameter was infinity, or if this parameter was, let us say, 20,000 or something, what would happen? So this will kind of help you internalize your entire concept. So that is why, in many ways, virtual labs are a very great boon. And in this scenario of COVID, etc., where we are not able to come to the class and to the laboratory and do physical experiments, the usage of these experiments has become very, very high. It has multiplied by 20 times roughly. 20 is also a small figure. Earlier, we used to have people who were using virtual labs mainly because we were conducting workshops. Maybe 2000 usages or 2000 experiments were performed by students. 2000 person experiments, that means one person doing an experiment is a usage. So like that, maybe around 2000 person experiments were happening. But now after this has started and the whole system has started getting used very heavily, the usages in the last 9 months has been 2 crore usages, 2 crores. Where is 2000 and where is 2 crores? And out of this, roughly about 7 to 8 lakhs is coming from overseas users, from many people who are using it. And the number of users are running into something like about, say, 20 lakhs, 25 lakhs. See, the total number of engineering students that we produce in this country is roughly, for all taking all the 4 years, is roughly about 60 lakh students. That is about 15 lakh students pass out every year from the final year. So out of the 60 lakhs, if 20 lakh students are using them, you can imagine one third of the students across the country are using virtual labs. So this is the kind of scale, and its relevance has become very evident to everybody. People are using it without any kind of workshop. People are using it on their own. Okay, so now I just want to see here, there are two modes in which virtual labs are being propagated. One is by doing a small workshop. Like we used to, before the pandemic started, we used to actually go to the colleges and then give them a demo of the virtual experiments. And we used to ask the students to, you know, do about 15 experiments and then list them out and all that. So that way we were highly limited in our outreach. We couldn't reach out to too many students. So the figures that are shown down below in this presentation, the colored blocks that you see, are giving you various parameters that are a result of that kind of workshops. And we are doing this from 2000, say 12, 13, like that we are doing for the last 7, 8 years. You can see the number of participants at 2,61,000. Only 2,61,000 participants have done it. And now I told you it's something like about 20 lakh students. And the usages, which is one person doing an experiment. When I say doing, it doesn't mean that you need to get into the experiment in detail, because every experiment takes a long time. I'm talking about doing plus browsing, finding out which experiment is interesting. Should I do this? Should I do that? That actually was only about 34 lakhs. But now it is 2 crores in a short period of time. In 8 years, these are the figures. Whereas in the virtual scenario, now in 8 to 10 months, the figure, that means from January till now, the figures are, as I told you, 20 lakh usages. So basically what I'm saying is that this has become very, very highly popular, and a lot of people, it's probably one of the most used initiatives of MHRD, and it is totally free. Okay. So now this is broadly an overview of this. And these are experiments. Now let's get into the presentation. But before that, let me tell you that MHRD has built this consortium project where there are 11 institutes or maybe 12 institutes, leading institutes, who have contributed various simulated experiments. These are all the 7 IITs, IIIT Hyderabad, College of Engineering Pune, Dayal Bagh, Amrita, and I don't know, NIT Surat. Well, I don't think I missed anybody, but basically I will show you the list also. So these are the institutes who have prepared experiments which are relevant to their own curricula. So it's quite likely that some of the experiments that are relevant to you, which are prescribed for you, are not there. In which case, that's a misalignment. That means you have the freedom to develop those experiments yourself and put them here. So now another very important thing about any of the virtual methods of learning is that essentially there is an aspect which is about how you actually use the methodology, or how you use the tool to benefit. See, all these are ICT tools. That means information and communication technology based tools. So you have a learner in this. You have a learner, and you have the source of knowledge located somewhere else. So these two are getting connected through your internet. So all your e-courses and all are getting available to you. They are being built by various people and placed into their servers, and then you are connecting them and picking them up. See, here the missing link is the teacher who is there in the classroom. See, many concepts can be understood very well when you read them, but then they only give you a broad outline. And maybe you are in a position to actually, some students are very good, they're very sharp, so they can go beyond what is said there and they can search here and there and find out. But essentially, this plus sign, I said learning is equal to mechanism to connect to the source plus strategy to learn the knowledge content. So this plus sign is extremely important. Now, in the e-learning methodology, you have only the source that is available to you and the pedagogy, which is to some extent built into the e-source. That means whatever content you're reading. For example, in virtual labs, there's a procedure. So the procedure is giving you a certain way of learning. But then there are many aspects of learning which are not just what can be documented. It has to come through a certain way of learning, which is what is called the method of teaching or the pedagogy, or there's so many words for that. So this part which the teacher used to provide is not there now. So it is important that when various concepts are being taught in the class by the faculty, they try to use the virtual labs and then teach. I'll give you an example. Uh, let's say you want to, the instructor is, the faculty is teaching about flux lines that come when due to a magnetic field, when current is flowing, etc. So typically in a practical experiment that you're doing, you're looking at it in an oscilloscope screen, and then you are kind of varying the inputs, current, voltage, etc. Maybe you're varying the resistance, etc. And then you are trying to watch the flux lines move up and down. But in a classroom, when you're teaching, you don't have that. So if you take a virtual experiment where all these parameters are changeable and you're seeing on the screen, you can actually watch what happens when you increase the current, what happens when you increase the voltage that is coming in, and how the flux lines will change. All these very colorfully through a video or through a visual experience you will get. So your pedagogy is addressed to a large extent, which would mean that you're learning, and it's anything that you see stays with you more than anything that you do. So what is important is this is more a pointer to the faculty when they teach online, or even when they are teaching in a classroom physically. Use of virtual labs as a tool to convey concepts is very important, because it kind of puts through many things which you can't, through talking or through showing a PPT or something, you can't really convey. So this is a very important aspect that we should remember, not only for virtual labs, but for any kind of e-learning. Today, students are just picking up any kind of e-learning methodology, programs that are there, NPTEL, this, that, and all that. They get certificates and they show them when they go for interviews. Believe me, the moment you show a certificate, the person sitting on the other side is tempted to ask you a question on that. So if he asks you a question, how much of what you have learned in that e-course would you know? You would know only if you have internalized the content. That means you have adopted a certain way by which you have internalized, a way by which you have understood it thoroughly, and it stays with you. So please remember that picking up any kind of e-course that is there and then doing a course and getting a certificate and piling up certificates is actually a disadvantage to you if you don't use the right way of learning and absorbing. I'm saying all this because this is very relevant. I've been watching in all my years of, you know, I have been involved with education for the last 12, 15 years, and I'm watching a lot of students, how they respond. Students want things to happen very quickly, and they just have half a minute time to pay attention to something. No, that is good. I mean, they are all very sharp. That is good in one way, but if you want things to stay with you, you have to remember that you have to absorb and internalize. The global statistic is that when you get into a class, listen to a class, and come out, when you come out, you remember 40%. 1 week later, you remember 20%. And as you go along, you will start forgetting the whole thing. You probably will remember the name of the subject and one or two words here and there. So it is very dangerous to get lots of certificates and not know what the content is. Okay, so this is as much as the introduction, and I felt it is very important for me to say this to you because uh, unless you know that it is something that you need to work on and absorb and use again and again, it's not going to benefit you. Okay, so now what is virtual? What do you mean by virtual? When you say virtual, I actually mean something simulated with which you can play. And I do agree that computer science people, for them, everything is virtual. So it is easy for them to kind of see the map between the virtual labs that we have here and the subject of computer science. So now I've brought in a few points that are important here. Anywhere, anytime you can use it. And colleges which don't have all the infrastructure that are required for them, all those infrastructure are built into these simulated experiments, and therefore the learning that comes from experiments where there is no infrastructure, this could be substituted. Also remember that we are not saying that these virtual labs will eliminate physical labs. No, this can be a supplement to them. They can be contributing very heavily, or they may be just a marginal, they may be improving your knowledge marginally, but they are essentially a supplement which you need to use accordingly. Alignment with the curricula, we are improving the alignment with the curricula in the sense the experiments prescribed by you. At this point, we believe it is somewhere around 50 to 60%. That means 50 to 60% of the experiments that you actually want in your curricula will be available here. The rest of the 40, well, we need to build them, and all your colleges have to contribute to them. Then it's a teaching aid for the faculty, as I told you, and the effectiveness of learning cannot be replaced, cannot replace the pedagogy or the teaching methodology which the faculty brings in. So this is a support to that. So now virtual labs is actually, as I said, it's a consortium project under the NMEICT project of Ministry of HRD. So these are the IITs, and this is NIT Surathkal, Amrita, and College of Engineering Pune, Dayal Bagh. These are the institutes who are involved in building these experiments. And on the right, you see the physical workshops that we used to do till say up to till March end. We were doing physical workshops from March end of 2020. So this is typically how it looked like. We would have a collection of 100 or say 60 or 100 or 50, depending upon the size of the classroom. And we would do multiple sessions of the same classroom. We would have one or two of our own people who would be guiding, and each of you would be sitting in front of your computer. And after listening to the talk which I am giving you just now, something similar to this, you would actually see one or two demos which we will be giving you right now also. Then after that, you will be asked to do about 15 experiments, each of you, each of the participants. When I say do, I mean It could be browsing, it could be actually doing. Maybe you do one or two experiments which are interesting, and rest of them you browse and create a list of about 15 experiments which are relevant to you. And when I say create a list, you actually must go into at least one screen and see what the experiment is, what is the objective, what is the theory. Maybe you just want to see simulation alone. You could see that, and then you should list them. See, when you list this, you get to know how to use the software. See, first time when you wrote Gmail, when you wrote a Gmail to somebody, you also didn't know. Somebody helped you out, or maybe you learned it through, maybe you raise questions on Google, or maybe somebody told you, or you yourself could figure out certain things. So that kind of initial learning is important. Therefore, for you to develop an opinion and to develop an interest, it is important that you actually do some experiments and then play around with this tool called virtual labs. It's a portal, and list those. So that is proof that the feedback that you give, the 15 experiments that you list out in your feedback form, tells us that you actually used the virtual lab, and now whatever opinion you have, that is really what is a fair opinion. Okay, so now I'm just sharing with you a few, most of the figures I told you already. So this is typically how the data that is coming out. 2.7 million sessions happened. 2.7 million sessions is about 27 lakh sessions. This is essentially the data that has come from 1st January to November. I think it is 5th or something like that. I can't see the figure here because I have a lot of photos, a lot of images on the right side from the Zoom. You can see the number of users are roughly about, how many are there? About 10 lakhs. Then 26 lakh sessions. See, bounce rate is very important. See how many people actually stay on there. 31% is the bounce rate here. And the average session duration is about 7 minutes. That means students are actually doing experiments, because 7 minutes is equal to roughly two Hindi songs or two Telugu film songs. So it's a good enough amount of time for somebody to actually dwell and see. So if it is 7 minutes, there are people who are spending 10, 15 minutes. There are people who are spending 3, 4 minutes. So broadly, this is how it is. And in each session, people are visiting about 6 pages. So this is also an important input to us. See, the device usage is um, also increasing. I will show you. This is about acquisition, how people are actually reaching out. How do they know? Are they coming directly because they know that there's a virtual lab, or are they searching from Google, or are they using any other means to access this? So we find that a good part of it is direct usage. That means most people know VLabs, which means that our outreach exercise is actually helping us out. 51% of the users are coming directly because they know the URL, they know what is this thing. So this is the next one is about the how the users are changing and how they're increasing in number. This is number of users versus time, that is month, etc. So this is about the different kinds of labs that are there. See, there is a concept that virtual labs are essentially mostly computer science experiments and all that, but that is not true. We have simulated experiments in mechanical, civil, electrical, biotechnology, and so all the different topics. So this is the top 10 labs that are being used with their page views and users. You see digital electronics by IIT Roorkee. This has got the highest number of page views, 2.3 million page views. It means 23 page views are there for this out of 18.295 page views that have happened overall for all. That means roughly this is contributing to about 10% of the total page views are coming from here. Now, users are 1.69 lakhs. So you can see the distribution. See, all the top labs are non-computer science labs. Digital electronics, basic electronics, virtual strength of materials, virtual sensor lab, electrical machineries, analog signals, then software engineering and data structures. After that, fluid mechanics is also coming in. So every week this is changing. So basically what I'm saying is every department, the usage is very good and usage can happen substantially. In fact, the non-computer science usage is much higher. If you see the data structures part, this is for 451,000. It's about 4 lakhs, whereas digital electronics alone is 23 lakhs. Okay. So basically what I'm saying is I'm saying all this to kind of help the non-computer science people feel that this is also relevant to them. Now, these are the different colleges, different institutes. IIT Kharagpur has got the highest number of page views, about 3.6 million page views, that is 36 lakh page views in this period from 1st January. And you see the page load time is very important because when you click on it, how long does it take for the page to actually display? If the time is more, then you will get frustrated and go away. So this used to be something like about 8 to 9 seconds. Now, most of the cases we've brought it down substantially to about 1 to 2 or 1 to 3 minutes. And the industry standard is 3 minutes, 3 seconds. 3 seconds should be the load time, the average load time. There are some which have got a lot of like dial bug experiments, which have got a lot of information to be put in. So questions I will take. There is somebody who's raised his hand. Questions I will take after I finish this. Okay, so this way I just want to tell you these are the top 10, and let me tell you that the top 10 labs uh, um, contribute to more than 50% of the total usage. These are graphs anyway. So anyway, here are some more labs, lab wise. See, what we have done is experiments are grouped into labs. A lab is nothing but a subdomain. For example, data structures. Data structures has got so many different algorithms. You have merge sort, you have quick sort, you have selection sort. Like that, there are a huge number of different algorithms, data structure algorithms. So we have grouped them 10 into one, and the subdomain is data structures, the domain is computer science, and experiments are listed out. So we have now, because of the heavy usage of data structures, we have now the old one, which is called the data structure lab. Then we have the new data structure lab 1 and 2, and probably future we're going to add one more because the number of the usage is very high for data structures. So IIT Kharagpur stands virtual strength of materials is also another very important. 20 lakh users are there, and 2 lakh users are there. Sorry, 20,000 users are there. So these are all the data that is cumulative. State-wise, Maharashtra is the highest, and I can tell you that about 10% of the usage comes from overseas. Now, this is showing you the distribution roughly. Uh, Electronics and communication has got the highest number of labs. They've got 31 labs. This is data which is picked in 2017. Actually, there's a lot of change that has happened here. We have added roughly about 300 new experiments. Therefore, maybe a 10% change would be there here. So computer science has 260. Um, Electrical has got about 180, like this. Okay. So now what is the structure of each lab, each experiment? It has got 5 sections. See, we have tried to make each experiment standalone and completely self-contained. That means what is the objective of it? What is the theory that is involved in this? Then what is the procedure that you use to do the experiment? And the actual doing of the experiment is what we are calling as either the experiment or simulated experiment or simulations. Then to understand whether doing the experiment has benefited you, we have a pre-test and a post-test. Of course, some of the labs only have older ones have got only a post-test, they don't have a pre-test. And there are some links about additional resources, where else you can go and pick information relating to these experiments. So this is broadly how the whole thing is structured. Now, this is for the faculty and even students. This is a mapping of the different virtual lab experiments that are there to various course sections in your curriculum. This is actually prepared by NIT Surathkal, and the link is given here. I can share this presentation to Dr. Varaprasad. And from this link, you can go and see for each of your own different departments and different course contents for different years, what are the labs that are from virtual labs that are relevant to you. For here, it is about computer science, and this is done for NIT Warangal's curriculum. So if you see course content CS 101 and 102, the experiment, which is basically talking about problem solving and computer programming. The experiments relevant are the labs relevant are problem solving lab and computer programming lab. Like that, you have got various topics and you can refer to this. This is very useful to the faculty, and students also may find, if they have some different concept, difficult concept which they're learning and that concept is not there in their experiment list, they can go here and pick it up and then do. This slide is about the outreach, how we are reaching out to different colleges and how we are reaching out to these large number of students. What we are doing is we have an idea of creating a nodal center network. Any college which is interested in our virtual labs, in taking these labs, using these labs and spreading them around, not only internally but also to the colleges close by, we are designating them as nodal centers. We have roughly about 1,600 nodal centers across the country. In this project, IIT Delhi is the lead consortium institute, and IIIT Hyderabad has done the cloud management, putting it onto the cloud, then doing all the integration part, and a lot of work has been done on moving this all the experiments from paid software to free software. Like for example, Flash is there. Flash is a paid software, though nowadays it is available. You can download it free, but I think it's also going to get phased out. We have converted a large part of our labs into JavaScript. In spite of it, there are many labs which are, and all the IIIT labs, we have a prerequisites link where if you click, you can actually, ensure that all your software which is not available in your system will also get downloaded. Like for example, Flash Player and Java, some updates on Java, some patches, etc. on Java, etc. Now, we also have a concept of a virtual box. See, this is very important from a user perspective, faculty and the IT people, I mean, people who are managing the network in the systems. For them, it's an important feedback. We have the concept of a virtual box. In that virtual box, we have installed all these kind of software which are not available. And once you install the virtual box in each of your machines, then whether the software is available elsewhere or not, whether it is downloaded into your machine or not, it wouldn't matter. The virtual box would contain everything, and then you can start using any experiment without any impediment. We have introduced that, and that link would be available shortly in our website, and we will communicate to you as soon as it is ready. We'll communicate to all the nodal centers. So now CMR Technical Campus is also a nodal center. It has been a nodal center for some time. Dr. Varaprasad was one of the initial group of people, group of faculty who actually, took virtual labs into their colleges. So this is basically saying, that all these nodal centers operate together in their one network, and they cover the entire set of colleges that we are actually looking at. Also, a lot of communication happens through these nodal centers. New experiments that we are developing, or we are doing announcing an internship, or we come together periodically once in 6 months and talk about what is the experience that each of you have. But at the same time, each nodal center has got a target of delivering 4,000 usages per semester. 4,000 usages is 4,000 person experiments. That means 2,000 students doing 2 experiments each, or 4,000 students doing 1 experiment each. In a group, in a university like CMR, I think 4,000 people is nothing much. So you can, or maybe you can do, as you said, you can divide this to all your different departments, and each department picks up some experiments and then gets their students to do as a supplement. So in any case, whatever be the approach that you take, each college is free to take the approach that they want, but you have a commitment as a nodal center to deliver a certain number of usages minimum. And they also have the advantage of being the first to be able to get new information, new labs that are there, and also the opportunity to form groups and develop new experiments which can be taken up and put into our virtual labs, for which we are providing you all the process, we are providing all the review, and we are ensuring that all the information required is available, but the effort has to come from the college. So that's as far as the virtual lab, about the lab and what's happening around and why it is important, how you should use, etc. So Professor Venkatesh Chopella is an associate professor in computer science in IIIT. He is the principal investigator. He's called in MHRD calls them as PIs. So these people are the single point contact for all the activity relating to a particular project happening in that particular institute. So Professor Venkatesh Chopala heads the virtual labs here in IIIT Hyderabad. So we have fairly good. We are IIIT Hyderabad as a virtual lab center is developing new experiments, is maintaining the all the experiments of all the institutes on the cloud. We have all the experiments available on Amazon, and all the code is available in GitHub. Anybody who wants to see the code of these experiments can ask for the link, and they can get into GitHub and see. If they feel some changes are required, they can also make those changes and put them up. Then that change will be reviewed by the owner of that experiment, and then only it will be merged into the master. But you are free to put in whatever changes you think are required in the experiment through your own branch. Okay, so anybody who knows how to use GitHub, they will know it, and you can learn from your professors. It's a very important repository, a version control system plus a repository. And I would advise that every single student of you, whether he's a mechanical engineering student or whether he is a computer science student or any department, to create your own handle in GitLab. I feel GitLab, which has got a certain amount of management also into the repository. It's an improvement, or it's a newer version of GitHub. GitLab it's called. So there, when you put all your content as you are using it, whatever you have developed, whatever papers you have written, whatever study you have done, it remains there throughout your this thing. It is a repository. And when you go for an interview and say, this is my GitHub handle, then before he actually starts interviewing you, he knows all about you, what all work you have done. You need not say something in your resume. People may not even look at resumes. They are looking at your GitHub handles, they are looking at LinkedIn, and they're looking at these kind of things. So GitHub is something that you're all mostly first year students. So all of you must open your GitHub account. It's called GitHub handle. So, and then it's a very easy and simple process. So there you can create different repositories. This is my classwork, this is my project, this is my intern, this is the new work that I'm doing on my own. These are my interests in music. These are the books that I read, and this is what I learned from them. All these things, and you can put copies of your degrees, etc., also into that, and your experience certificates. Everything you can put. Basically, GitHub is a developer interface, but GitLab gives you also these other additional features. So please, it's an advice to you to keep your GitHub and GitLab handles, and they will be the ones which will talk about what you are doing. And once somebody sees it there, he is convinced that you have actually done it, because it is a version control system and it has got a timestamp, and any change that you make is actually tracked out there. If you make it a spelling mistake and you're correcting your spelling mistake over what you had written earlier, it will also record that on so and so date, so and so person has actually made change, and this is the change that he has made. So you also have the comment say why you made the change, you can also put it. So please remember that this is an excellent tool for all of you. Okay, so this is as far as telling you about virtual labs and general advice that I gave you. Now what we will do is we will actually watch a few demos to see how the virtual lab is, and then after that we will take questions. Okay, if anybody has questions on what I have spoken, I think there was one hand that was raised. You can ask, and then I can respond to that. And then after that, Shashank will talk about digital electronics. He will give you a demo of that lab, of that experiment, and what his experience is. See, we thought doing all these sessions that bringing in a student and sharing his experience with you would have a lot greater impact on students, because students understand students better than anybody else. So after that, we will actually, I will show you one or two experiments myself. Just to give you a feel that mechanical, electrical, all these are there. I can show. I'm a mechanical engineer. I'm not a computer science guy, but I have learned something from virtual labs alone, and I can share with you. Please remember one thing: it is very important for you to relate what you are learning to where it is going to get used, how it is going to get used, and what is the benefit of learning this. You must always remember that. That is when it will make a difference to you. Okay. So, any questions if you have, I will answer them right now. Otherwise, I can take them at the end of the talk also. Um, if you have, you can ask. Otherwise, we will move on to Shashank presenting one experiment.
Emma, if anybody is having any questions, you can unmute yourself and ask the questions to Professor
Yeah, there was one hand that I saw. I don't know whether it is related. I will
Sujit
look into
Bhasham.
that. Yeah,
Yeah, Sujit, do you have any question?
Is that my audio is
Yeah, yeah,
listenable, sir?
audible.
Hmm. Sir, is the virtual labs is used to the students from engineering first year onwards?
uh, yes. That's why I said if you do after this session, when you do your when you fill the feedback form, you have to list out all the experiments that you think are relevant to you. Yes, even right from first year onwards, you have experiments like you have programming. You have got then you've got.
Experiment which we have to know about the internal structure. All the details will be made by our
Yes.
own, or virtual labs will give all the details about it.
Yeah, when you see it, you will know the virtual labs is a complete system. So it has got a, there are 5 sections in every virtual experiment. The experiment has got an objective, it's the learning objective. That means at the end of this virtual lab experiment, what is it that you will learn? That is the learning objective. Next, it will have theory. What is the theory relating to the experiment? It will explain all that is relevant to the experiment. Then it will have a procedure as to how to do the experiment. That means 1, 2, 3, 4, 5, 6. You can read them. Then you'll go to the simulation section where you're going to execute the procedure and do the experiment. And you can also have, in majority of the experiments, you can change the parameters as you want. And then see if I increase this to this, what will happen? If this is 0, what will happen? All that you can play around. So that playing around is very important because that is what tells you, that is what gives you the confidence and a little comfort on the whole thing, and you will start internalizing the concept because that happens only when you analyze something. Okay. Then last of it is a quiz that will tell you whether you have learned or not. So if you feel that after doing the experiment your quiz answers are low, you can go back to the experiment, do it once again, or any number of times and learn the theory a little bit more and then redo the quiz. So the quiz will stay with you as long as you are within the experiment. The moment you come out of it, everything will be lost because the quiz runs on the browser. It is not linked to the database. Okay. So this is
Sir,
the question, and as you see it, you will get to understand. That is why we have demo sessions.
okay, sir. Thank you.
Yeah. Okay. So
Yeah.
now I'm moving out, and I request Shashank to go ahead and share his screen.
What is the display name of Shashank, sir, so that I can make him host?
Shashank has got a. He will actually go to the virtual labs, and he will open one experiment and run through the experiment, and after that he will have a PPT also, which he will show.
No. I'm asking, is he joined, sir?
He has joined. He is there.
What is the name displayed there on the
Shashank, what
screen?
is your mail ID? It's called repressor, I think. Repressor is what it's shown as repressor.
Yeah, repressor plays.
Yeah, please make him the presenter.
So what does GitHub stands for?
Um, GitHub is okay. If you want me to know, explain what is the expansion of it. I'm sorry, I'm not. I don't know about it. I don't think there is any specific expansion for it. But it is a hub. That means it is a hub for information. That means it's a It stores all the information that you wanted to store. That's fundamentally what it does. But it has got lot of features for developers to write code, enter code, etc. So the entire virtual lab code, except for a few experiments in few labs, is available in GitHub. So once you have an access to GitHub, you can go to anything that is there and then do whatever changes. So the beauty of this thing is you can make, suppose I have developed this experiment or I have written some code. Now you feel something is not right in that. So I will, there is a facility by which you can, download that code and then you can make whatever changes you want and push it back. Once you push it back, it will stay there as a branch of the main code. So the original owner, whatever he has written stays there, and what you have written is visible there as a comment or as a branch. So for a developer, the limitation of space, time, and knowing each other and all that is not there. So particularly open source, when it is getting developed, they use these kind of repositories. So GitHub is a repository where you can put everything. For developers, it is a very good interface. That is why I suggested that you become not only GitHub but also GitLab. GitLab may lot of management, project management kind of functions are also there. I hope I have clarified to you what it is. While this is going on, I will also check what the GitHub, what is the expansion, if there is any expansion for it. Okay. Am I clear, sir?
Yeah, yes, sir.
Yeah. So meanwhile, I will also see what the. It's a good question you asked. I didn't know it. So please, Shashank, please go ahead.
Yeah, thank you, Ravi sir. Hi everybody, I'm Shashank. I'm a 12th class intern actually at Virtual Labs. I'm just going to give you a quick demo of Virtual Labs and a quick insight into what I think of Virtual Labs. So here I'm at the website of Virtual Labs, as you can see as I'm sharing my screen. So here I'm at the Virtual Labs, and the first thing that you can see are the objectives that Virtual Labs has. Any student can obviously go through this. And as we go down, we can see the different domains of Virtual Labs. So we have electronics and communication, computer science, other different domains where any students follow doing that particular domain can actually follow to see which experiment they'd like to do. Also, we can see the different participating institutes that have actually contributed to making Virtual Labs possible. The different IITs are here, IIIT Hyderabad and other institutes have contributed to making Virtual Labs. So this is basically the first page of Virtual Labs, and I'll go into one of the domains. So here we can go to electronics and communication. So here we can see all the different labs that are ready for use and the different.
Shashank, sorry for interruption. Can you take any CSE?
No, I'll take the CSE part. I will show you some CSE experiments. Now let him show a digital.
Thanks a lot. Thanks a
Whatever
lot.
he's showing. Yeah, I'll do that after this.
Right, right. I mean, the reason I'm doing the digital electronics lab is because it's an extremely popular lab. So that's one of the reasons, and it's very easy to understand. So as okay, so we can see all the different labs that are actually ready for use here, and we can see the different institutes that have actually contributed to making these labs possible. So if I go to the digital electronics lab right here, we can see that the IIT Roorkee has basically contributed to that particular lab. So we can click digital electronics. So you can see here that this is the template for any lab. We have the introduction, the objective, list of experiments, target audience, course alignment, and feedback. This is how basically every lab is going to be, and this is the template for it. So it will be basically very easy to understand as after I show you this demo. So let's go to the introduction first. So we can see here that they're welcoming you to the digital electronics lab. Then we click on objective. So to basically learn and understand the concepts of digital electronics, obviously very straightforward. Then list of experiments. Here we have 12 experiments, and here whichever one corresponds to the student, obviously they can click on it. Then we can go to the target audience. So which audience would be better suited to this particular course, for example, undergrad, BTech, etc. But of course, any user can obviously try and understand this lab further, but these are the students that will be more aligned towards these labs. Then course alignment. So the course alignment is going to be basically where it has been taken from, which particular course it aligns to. Very straightforward. This is where it has been taken from. So the student, if it wants more information, then he can obviously go and check. Then feedback. So feedback, obviously for this particular lab, if there's any improvements or if you liked it or disliked it, whatever opinion you have to give, you can obviously share it. It only takes a couple of minutes. So after sharing the feedback, then we'll improve on the points that are given to us, and we'll try to make the lab a better experience for every student. So if we click on list of experiments here, I'll go through one of the most simplest experiments there is, so that even people who are not taking this can easily understand what is the true crux of virtual labs. So we can see here that we're now in the electronics and communication engineering domain, the digital electronics lab, and now we're in the logic gates experiment, the verification and interpretation of truth tables for logic gates. So here you can see that is the aim of the experiment here, to understand truth tables for the different logic gates and draw the truth tables for them. And for more advanced students, obviously it's to understand the resistor transistor logic, which is not needed here. It's just there in the end, but for this explanation purpose, it isn't needed. So here we can go to the theory. So the theory is extremely important. So here we can see that the theory is going to be providing all the information that is necessary to basically make the student understand what the lab is about, and so that they can proceed on and get a thorough understanding of the concept. So here you can see that the different 7 gates are being provided, and the diagram of one of the gates and the truth tables and all the explanations have been provided, so that the student can have a holistic learning approach to first understanding all the concepts that are behind this particular topic. So after going through the theory thoroughly, there will be a pre-test. So the pre-test is to basically understand the fundamental concepts, whether the student has a small amount of knowledge or the basic fundamentals of the concept will basically be clarified using this pre-test. So after finishing the pre-test, you can click the submit quiz and you'll get the answers of what you got right, what you got wrong, you'll know. And depending on that, you can obviously work on yourself or move on to the next. So here we can see procedure. So the procedure is the basically the pre-step towards the simulation. It will tell you how to do the simulation. I'll show you that right now. So for example, in the AND gate, they're giving you 4 steps to do it, 4 steps to follow so that you can do the simulation correctly. So I'll show you what is the simulation exactly. So here you can see this is the simulation, and here also there's a button to pop up the procedure. If you click on that button, you'll get the procedure side by side, and using the steps that are given in the procedure, you can do the simulation. So let's click on AND gate. So no need to remember anything, but I mean the steps are to connect the battery, turn on the switches, the green light indicates the current, and turn on both switches and the bulb will glow. That's the simplicity of this experiment, and this is how it will basically work for most experiments. It'll be very, very easy, straightforward. Follow the procedure and you'll get the practical learning. Right. So just give me a second. Yeah. I went back from accident. Let me just go back. Yeah. So now we were at the simulation and I showed you what is a simulation. Now we can go to the final this thing, which is basically the post test. So the post test will basically tell you how much you actually truly know, because all the questions here will cover the entire theory of the entire chapter. So if we go down here, you can see that these questions will be slightly more advanced than the pre-test, and it will give you the entire questions that cover the entire syllabus, so that the student will be finally done and fully understand this concept. And after he's done, like I told you before, you can click submit quiz. And after clicking submit quiz, it will take you and tell you what you got wrong. Depending on what you got wrong, you can go back to the theory or go back to the simulation, understand why you got it wrong, and then work on yourself and fix your concepts, etc., until you're done. So after post test are the references. Suppose you have a doubt that isn't being clarified by the theory, or if you want some extra information in the topic, you can obviously click on these links or follow these books to just get a better information of the concepts. Finally, feedback, like I told you, for this particular experiment, you can obviously give your feedback. If there are any improvements, uh, please let us know through the feedback and we will try and improve the lab, which we are continuously doing, because improving is a constant process. So that is basically a very, very quick and simple way to explain and give you a demo of the electronics and communication engineering domain, the digital electronics lab, and the experiment, which is the logic gate. One are very simple, and this is how the template will be for most experiments. Follow all the steps and it will all be okay. It will be fine. It will be extremely easy. So now let me just give you my opinion of virtual labs and what my experience is as a 12th grade student. So if I show you my slide here that I've made for easier understanding. So there are a variety of pros and points of improvement that are required for virtual labs in my opinion. So the first pro of virtual lab is that it kids that do not have access to laboratories, like kids living in rural areas, that schools who do not provide laboratories, virtual labs provides them with an even playing field compared to all the other students, so that they can also have enjoy practical learning. And also virtual labs improves the learning experience because it provides easy practical learning. And during COVID times, obviously most people cannot have access to laboratories, so that element of learning has really been cut out of people's lives. So virtual labs provides that easy practical learning during these tough times. And also the variety of experiments they have allows them to expand their user base. As you saw, the amount of domains that they have, and if you take each of those domains, they'll have a certain number of labs that are ready for use, and those labs will have a certain number of experiments. So if you calculate the total number of options that they have for kids, that means that they have a lot and lot of experiments that many people can benefit from these practical learning experiences. And finally, like I've told you multiple times, the simulations really create a good fun learning experience for all the students. Now, points of improvement. That not everybody learns at the same pace, so maybe the theory could be divided into levels of difficulty. And also, many students would like to learn from a teacher rather than just reading text. Therefore, video content could be posted to increase all the interest levels of the students and accumulate more users, so that they can touch the lives of many other people who are actually trying to enjoy practical learning. Finally, if when you, like I told you before, when you click submit quiz in the post test and the pre-test, sometimes the explanations are actually not provided for the answers. So therefore, the explanation should be provided for all the answers, so that the student knows why he got wrong instead of looking for why he got wrong. Instead, it will be more efficient and fast for the student. So this is basically my thoughts on virtual labs, and I also gave you a quick demo. I hope you guys understood it. And now I'll hand it back to Ravi sir.
Thank you, Shashank. This was just a view because ultimately what you should be seeing in this presentation or in this session is essentially about how to use the portal. It's not about how you're doing an experiment. It's about how you're using the portal. So one second, I just changed the screen here. Share screen. Okay. Okay. So what I'm saying here is that it's not so much about doing an experiment. It's more about understanding how the how the whole structure is, where what experiments are there, and what are the experiments that I can pick, and what are the how is an experiment structured? That means uh, what simulation is there, theory is there, test is there. So how do I go about moving across all these? And as a result, I get to understand how useful it is going to be for me. So this is the purpose of this meeting. This is basically a meeting or a presentation which is intended to familiarize you with the virtual labs. See, the actual doing of the experiment is between you and your faculty because, see, we are not technical experts in terms of all the subjects. See, for example, I'm a mechanical engineer. I can show you some mechanical engineering experiment. Maybe I can help you do some of them also. But then computer science, for example, I can show you a few because I've been involved with computer science for some time, so certain knowledge I have. But as far as your curriculum is concerned and how the experiment is useful to you, how the theory part of it, that your faculty should help you, but they can also only add the small amount. Bulk of the learning has to come from you because the entire content that is required for you to learn is already there in this. So the whole effort is your own personal effort. I mean, this is what I want to say. Okay. So now I will move on to the actual site, and then I will show you some of the experiments that are that you can actually we can I mean how to do these experiments. You can I can I think I messed up somewhere in sharing the screen. Okay. So now so as you have seen, this is the virtual lab screen. So screen sharing has stopped. should share the screen again. Give me just 1 minute. So are you able to see me? Are you able to see me? Are you able to see me? Are you able to hear me?
Yes, sir.
Okay, because I moved around here and there, so I thought. So now this you already know how to get here. Um, this is the landing page, vlab.co.in. Then you saw some experiments from digital electronics. Now there was a demand for computer science. Are most of you from computer science only, or are there other departments also?
No, no, sir. Only computer science and engineering and information technology.
Okay, so I will share with you computer science now. Computer science, there are a huge number, like very basic things like HTML and all that. And there are data structures, which is very important. So what I would go is I would probably start with the very basic thing, like for example, um, computer programming maybe.
Sir, above problem solving lab is there. Computer programming lab is also.
No, what I will do is no, my idea here is to explain, I'll go to data structures. See, data structures will be the main, one of the most important experiments that you will be doing, very critical to you. At the same time, it will be like the number of data structure algorithms are huge provided. And data structures that we have here is the older one has presented the experiments differently, and data structures one has presented it differently. So I also want to share that with you. If you want us to go into problem solving also, we will go in, but problem solving is more of writing code on your own. So in a demo, it's very little that I can show you. So if you want, I can show you that also. I can go to problem solving and show you. So it is basically more of um, writing code on your own. So if you go into the simulation part, it's called the experiment here. If you go here, it will present you the IDEs. So you need to write code and verify. So it's more about writing code. It's what you need to do on your own. So that is why in a demo, it's hard for me to demonstrate this. So I will go for other experiments which are more interesting and which are where a certain amount of relevance is there in terms of seeing what is there. Here, you're just going to write code and it's going to give you some hints and you're going to, so it's more about how to write programs and how to solve specific issues that are raised out. So what I will do is I will get back to some other experiments in computer science only. That's it. I'll close this window. Sorry. I'm just getting mixed up with this interface. Yeah. So now I'll show you. This is what Mallareddy University people asked me, because they were mostly first year only computer science people. So what I did was I did that. I did not problem solving, but computer programming I did. But that's a slightly different lab. It's more like an experiment. So you have different kinds of small little problems which are posed here. For example, numerical approximation. So they have a graph and you're measuring the area under the graph. So then there are functions And so all these, I'll just demo you one. This is a computer programming lab. It talks mostly about very fundamental principles, which mostly in first year you would be teaching. So here again, the structure is introduction, theory, objective, manual, which is basically nothing but the procedure. It's an add-on to the procedure. And then there's some reading. The simulation part of it is what we will go into. Now, sorry, what we are doing is, suppose you have a graph like this. How do you use numerical approximation to calculate the area under this graph? Now, it's important for us to understand that this is not purely a mathematical thing that you're doing here, but it is extremely relevant for so many things that you do in life. See, the work that you are, for example, if you want to do in people who are going to do data analytics, for them, this is going to be a very important concept. So what you're doing here is you are looking at the behavior of certain actions that happen in common life, and you can look at the signals which you are processing when you are triggering some function in a system. So either way, this kind of curves are important, and the area under this curve is what you calculate here. So as we go along, I'll just show you that part also. So procedure is given here, further reading is given here, and then we can get into the actual simulation. Procedure is given as you have seen here. Then you go back here. There'll be one, go to home, simulation, you go. So now if you see here, this is a typical curve that is taken and you're calculating the area under that. So we will define the limits of these two, and then we will start calculating. So there is a program that is being used here. They have given you the program, and they will show you how each program step, when it gets executed, how it is calculating the area. So what we do is, so here is the problem. Given a well-defined, well-behaved, smooth function, integrate it over the given limits of integration, approximating solution to integral integrate a smooth function, and integration limits. See, these limits are between 0 and 30. These a and b factors are there. A and b means this axis is a and b. So what we are doing is we will define in our experiment any two values which will determine the parameters under which you want to calculate the area. So let us say I put 10 here. I put 10 here, and I put, let's say, 15 here. Just two numbers, which is falling within that. 0 to 30 are the two end limits. So now I start it. And then I said next. So now you see it is telling you, highlighting you which line of code is actually getting, is functioning. So first one, that is, it has initialized this one. And then if you see here, it is scanning it and getting the values. And then it is creating the base parameters. Now, if you see the next step, you'll actually see it calculating. See, you can see the graph here. Under the graph, there is an area which is colored. So then the iteration will start, the loop will start running, because you have given the two limits of 10 and 15, and you are asking it to run again and again and calculate the area. So you have given what is the formula for calculating the area. This is the numerical approximation. See, there is a certain amount of area which gets left out, but you're trying to make the approximation as close as possible. So this you will learn, I mean, your faculty will teach you that. So now as you go along, every step it is re-executing that, and then it is increasing the area. And at the bottom here, it is writing out what is the area it is calculating. This sum is the area. So every time you're incrementing the previous sum with the new, this one. That means basically what you've done is you've divided it into rectangles, and each time you're calculating, the height and the width, and you're calculating, right? So that is really what is happening here. So these bottom, I think the numbers are very small, but this is what the outcome is. So at the end, when you finish all the 15, let us say you do it multiple times, when it touches 15, it will give you the final output. See, now it is written the final output. So this is really what your experiment is all about. Okay. So now it has got reset once it has reached 15. So this is one simple example. See, in computer science, most of the experiments will be fairly simple like this. Whereas if you look at other mechanical or civil or electrical, you'll see a lot more. I mean, from an experiment perspective, the visual experience will be different. So now let's go back and see some other experiment. Um, so like this, you can perform. So I would go back. Of this creating an issue for me. Yeah, now let's go to data structures. This is the old data structures. That means the data structure experiments which were created prior to 2019. So here again, the template is the same as Shashank told you, is the introduction, list of experiments, etc. This prerequisites is something which I wanted to tell you. I told you that there are certain kinds of plugins which are not available. So if you want this, you can actually look at this. And then here there is a link here. If you click on that link, it will give you a document and you can download the Flash. Now from December on, after December, Flash is being phased out. So you won't get any support from the net. So we are providing you a link, which is a virtual box basically. So you get into the virtual box and do the experiment through the virtual box where all these are installed. Okay. So now let's look at the list of experiments in data structures here. Let's look at pick any one of them. Let's say sorting by arrays, let us say. Then the sorting by arrays, you have got multiple experiments. So now you want to see which are the ones. So let's go into simulation. Then you have three options: quick sort, merge sort, insertion sort. So let's look at let's say merge sort. It's just this one. Now see how it will show you how the algorithm actually executes. Okay, so you need Flash. I've clicked it. I've allowed it. So now if you let's just do some random input. Let's execute it and see how it works. So we'll ask for random input. So this is the program which is actually executing the merge sort. And let us put the inputs can be different numbers. As you know, in sorting algorithms, you are actually ordering the inputs that are given in a particular sequence based on a certain norm. So here we are going to give numbers and ask them to be ordered with and most of these algorithms will move the the largest number to the rightmost block. Okay, so they will order it like that. That means a descending order. I mean ascending order it will do. So I'm putting some numbers just from my memory or just from my thoughts. So I'm putting 25 first, then I'm putting 2, then I'm putting 100, then I'm putting 999, then I'm putting it as 56, then I'm putting as 84, then I'm putting it as 9. So these are the numbers, and then I press enter. So now this gives me the actual experiment, how it happens. It gives you the visual experience. So the moment I click this go button, this arrow here, then it will start executing, and at the same time at the bottom it will show you what is happening. That means, see, any algorithm is essentially a sequence of steps, a way in which you're going to kind of solve the problem. So it's an algorithm. In an algorithm, you're trying to sort it. So you have multiple. About the other day I saw in Wikipedia, when I said sorting algorithms, it gave me 34 sorting algorithms it listed out. Now, what you need to also understand, and you will be told all this, but I'm just saying because you're doing the experiment, what is the importance of a sorting algorithm? See, a sorting algorithm is used by every search algorithm. When you go into Google, let us say, or any other source of information, when you ask for a search, when the search is happening, there is an algorithm, a search algorithm is getting executed. But the search algorithm will use a sorting algorithm to order it. Let us say you have an employee table or you have a student table. Now from this student table, you want to know who are the top 5 grade students. So now you will write a query, So if you know computer programming, you'll say order by employee, or order by student marks. You will say that. Yeah, and maybe you'll give some other condition for that. So when you do that, what it will do is it will take all the marks and order them. So each different algorithm will have different amount of resource consumption, different amount of time it will take to execute. Now, why that will happen, you will see here. Because some algorithms will take two numbers side by side which are there and then match them, and the larger one it will move to the right. Then it will pick the next one and go. Some what they will do is they'll divide the entire set into two parts and execute them separately. So this way there are so many different ways in which you are ordering it. So this is going to determine what is going to be the speed at which something gets executed and what kind of memory and what kind of space you need, what kind of all these kind of parameters get are indexed onto the algorithm that you choose. So if I don't worry about time, etc., the same student table, if I just say if I just write a command without any conditions and all that, and if the programmer is not properly taking the right algorithms in his program, then the time taken will be enormous. See, if I have a small table with about say 10 people, then it will not take much time. But if I have a, let's say, 2000 students there, it will take a lot more time. But if I have 10,000 students in the entire university, you imagine amount of time it will take, and the computer is the RAM and all the resources will be taken away by that. So the time taken will be huge. Or sometimes you get a message, you see, when you try to look for your mail also, it says timed out. That means the time taken to execute the algorithm has become so high, for doing the search has become so high that it has crossed the time that is normally allowed for a single transaction. So it will say timed out. So you have to do it again. So that means rush is more, volume of data to be processed is more, therefore it is taking more time. So this is the importance of a sorting algorithm, and a sorting algorithm becomes a major input into the search algorithm. So all that you are seeing here are related to this. So it's a very fundamental thing, and you need to know this. So now let's see how this experiment shows that. Now what it has done, it has divided the whole thing into two parts, and it has taken one part, and that part again it is processing. And it is ordering, you see. 2 and 25, it brought them, 25 moved here, 100 is here, 999. So it is sorted out in a particular way. It is writing here how it is doing the sorting. See that? So if you go to quick sort, it will do it differently. If you go to selection sort, it will do differently. So the ordering of this is being done differently by different algorithms. Watch what is happening down now. So this experiment is giving you the option to see how a merge sort algorithm executes. Now, if after some time, if you try to recall how the merge sort did and how merge sort and quick sort were different, unless you have repeated this and memorized this or got it into your mind, you will not be able to tell the difference. So this program gives you the option of repeating multiple times, as many times as you want. Okay. So this is broadly what I wanted to show you as far as this data. Now the same data structure experiment, if you go to the newer developed ones, how will it work is what I want to show you. So how do I go back here? I'm having a problem with this pop-up that is coming here, and I'm unable to go reach my screen. Okay, I will re-log into another session. So that's going to be out of the box. So now here I've gone into computer science again, and then I'm going into data structures 1, which is the new one. In this also, many of the algorithms which have been done last time, we are going to use them. What did we do last time? Merge sort is what we did, right? So let's do merge sort now here again. I want to show you the difference. And from a learning perspective, there are many other aspects which are added here to give you the ability to learn better. See, there were many comments saying that voice is not clear. Is it clear now? If there is anybody, please let me know. I'll try to correct. So now look at this list here. I mean, what is the menu? There is a pre-test to first know what is it that you have, what is it that, one second. Yeah, to know what is it that you know right now before you actually start doing. Then you go to the algorithm, which is divide and conquer. Then you execute the merge sort algorithm and then do an analysis of what it is. Analysis is relating to what is the kind of resource that is being used, what is the space and time. Space and time estimations are very important because all the different algorithms you can they compare in different ways. So then after that there's a post test, and then there is some support for any other reading that you would want to do, and there is a feedback. So if you go into pre-test, there's a recap of whatever you had learned earlier. Little concepts, little recap, and then it'll give you a quiz. So here is the quiz. I'm just showing you. You can do it on your own. So you submit it or you reset it, whatever. Then you go into this idea of what is divide conquer, what is the sorting algorithm as far as the problem is given is concerned, divide and conquer issue is concerned, and then you go into the merge sort algorithm. See, the important thing everywhere is that we have introduced a small introduction video. There is a student who is explaining to you about this. See, this is very important. Like whatever I'm talking and telling you here, every experiment has got a certain amount of knowing that you need to have so that you can absorb what is given there. So we have introduced small videos. This digital classroom that we built in IIIT was essentially intended to do this recording. I'm playing this for you so that you can get an idea. Finally, moving on to the merge sort algorithm. You already know about the split step and the merge step. We combine these two steps as shown in the figure in order to get the sorted array from this unsorted array. This part you see in the red is the split step, and one which you see in green is the combined, which we call the merge step. In a given initial array was divided into sub-arrays till we reached the point of having sub-arrays of length 1, and then we combine them in a sorted fashion, like 7 and 3 were combined into 3 and 7, and so on, as shown to get the final sorted array. Let's have a look at the demo that we have for you in the module. In this, you'll be given an array, and you can click next step to see how the array is split till the point it cannot be split further, and it reaches sub-arrays of length 1. After this, if we click next step, the sub-arrays will start to get combined, and they'll merge into sorted sub-arrays. At each step, you'll know which two elements are being combined as they will become green, and you'll see the merge empty, as you can see here. And in the next step, the elements you can see will be merged in a sorted fashion. As you continue, you will get this final sorted array. Let's have a look at the exercise for this module. Given an array of length 8, you'll have to specify the indices about which you need to split the array. So here, as the length is 8, you specify 4 and 5 and press split. At each step, you know which array to split by seeing the array which is in green. This array is in green and is of length 4, so you specify 2 and 3. And that array gets split. And now the array that needs to be split is shown in green, and you continue in this fashion. Now as you move on, you need to find 2 elements, specify 7 and 8, and then you see that cannot be split any further. Now you have to merge it. At each point, you will know which 2 elements the merged array will be shown empty and green. The elements to be merged are 10 and 43. You will specify the sorted order of these elements in the input field as shown, and then press merge. You will continue in this fashion.
Please make sure that you enter common field values for the sorted array. Finally, you reach the final step. You specify the whole array in a sorted fashion, and then you get the final sorted array.
Sorry, now we'll go further on this. Now you see, this part was over. Now let's go into the analysis part. See, I'm not showing you too much of, I'm not getting into everything, but I'm just trying to give you now analysis. What are you going to do in analysis? Time and space complexity. As I told you, this is very important. See, when you learn any algorithm, or when you learn anything, you must know where it gets applied, how it gets applied, what are the intricacies, what are the differences. This is the difference between an expert or a student who learns, who is sharp and who's not sharp. It's just the amount of effort that you put in to, analyze and, look at different combinations and see what if this happens, what if that happens, or go and look at some other source of information, read that and try to merge. So this kind of an effort when you put in initially and when it gets internalized, slowly your ability to understand becomes higher and higher. So this is how you need to grow. So here we have included all these, we have included the video and all that. Please don't think it is spoon feeding, but we are trying to see certain things are need an explanation. And that is why we have added this so that it is easy for you. See, time and space complexity. Let us analysis part covers all that. So here he'll explain all that.
Welcome to the analysis module of our experiment. Here we're going to be learning about the time and space complexity of merge sort. Then we're going to look at how merge sort is a stable sorting algorithm. And later we're going to try to compare it with other algorithms to get a better overview. First, let's see the time complexity of merge sort. We are now familiar with the merge sort tree. So let's assume that the initial array that I have is of n elements. For simplicity, let's assume n is the power of 2, say 2 to the power k. I call the first level as level 0. So at level 0, I have one array which has n elements, which is equal to 2 to the power k elements. At level 1, I'm going to have two arrays of n by 2 elements each. Similarly, at level 2, I'm going to be having 4 arrays of n by 4 elements each. If we try to generalize this, we can see that at level z, I'm going to be having 2 to the power z subarrays of length n upon 2 to the power z elements each. Make sure you understand this step before we proceed to the next part. Now that we have established that we have n upon 2 to the power z elements at level z in each array, let's get back to our merge sort tree. We know that we stop the split step when we have subarrays of size 1 each. So say this level is level n. At level L, I can say that I have n upon 2 to the power l elements in each subarray, which in this case turns out to be 1, since these are single elements. By here, looking at this, I can say n is equal to 2 to the power l. Remember how we did the logarithm during week equal to O of n log n to the base 2, because I have log n to the base 2 levels into n, which is the time complexity for merging at each level.
I'll show you this one here. See this one, remote triggered virtual lab on automotive systems. So there are certain software through which you will connect there, and you are going to enter the values in the equipment, and you'll actually see the equipment there. So that requires an appointment and things like that. But it is very hard to manage this. So we are not focusing much on this, and now we have a few experiments, about 50 or so remote triggered labs are there in various topics. Now, one interesting thing that I thought I'll show you was once again, metal forming. This is something where getting the equipment for actually doing metal forming is hard. Therefore, this experiment actually is more of a video kind of a thing. But it's see in a metal forming there are multiple combinations that are possible. You can have pressing, you can have cold forming, you can have extrusion. So many different kinds of processes and equipments are there, which will result in different kinds of applications. So what has been done here, I'm not going into the home page and showing all those sections and all, I'm just showing you what is relevant to this. See, equipment wise, there are two equipments that are covered in this. One is the upsetting presses, the other one is extrusion presses. Extrusion press, I don't know how many of you actually know it. In an extrusion press, you're actually using a force to extrude some form out of the larger piece. Whereas in upsetting presses and all that, you're actually deforming that particular piece. Like for example, if you have a small block of metal, you will shape that metal by doing upsetting. Whereas in an extrusion press, for example, you're forming, let us say, a complex part of the cap of some equipment. It will be like a cup. It will have some, projections here and there, some slots and all that. All that will be done through an extrusion press, where what they do is they will force the metal in certain conditions through a die, and it will come out with that form. So now for each of these, there are, let us say, for example, upsetting. You can do a gravity hammer kind of a press, or you can do one where there is a certain amount of speed that is built into this, or you have a knuckle joint press, or you have a hydraulic press of different varieties. You have a mechanical press, or you have a screw press. You can see experiments in each of these. For example, let us say hydraulic press you take. If you click on this, it will show you about a hydraulic press. It will be all, as I said, video recording. When you play this, it will show you.
A hydraulic press is a device in which a large compressive force is exerted on the larger side of the two pistons in a pair of hydraulically coupled cylinders by means of the relatively low force being applied to the smaller piston. The working of the machine is based on the Pascal's law. A hydraulic press consists of frame with 2 or 4 columns, pistons, cylinders, rams, and hydraulic pumps driven by electric motor. The hydraulic press are made according to the various product and process requirement. One of them is shown in this video. In the given video, we see that the two sections, with the left one depicting the various components of the hydraulic press, whereas the right one depicting the working of the hydraulic press. In the left side, we see the hydraulic press consists of various components, which include the hydraulic cylinder, which is mounted on the top of the frame. Inside the frame, there are various components, which include the ram connected to the punch and the workpiece, which is to be shaped. And at the lower end, there is a base. The working fluid is the water itself, which is kept in cylinders. The right side of the screen shows the working of the hydraulic press. Here we can see the piston which is being kept inside the hydraulically filled cylinder is being allowed to move to and fro in the vertical direction by the action of the hydraulic force, which is being applied by the incoming pressurized water. Initially, At the downward stroke of the piston, the water is being pressurized through the upper pipe into the cylinder, and during this stroke, the workpiece is being pressed hydraulically with the constant pressure made it to deform in a continuous manner. Whereas the upward stroke, that is the retrieval stroke, the water is being pressurized through the lower pipe into the cylinder or is withdrawn through the upper pipe only. A hydraulic press is a device in which a large compressive force is exerted on the larger side of the.
Okay, I moved out of that. So that is how you can see. Say, for example, here are the processes, how all these different processes happen, and here are the applications. You want to make a crankshaft, you want to make a screw head. What are all these different things? How do you actually do? So you want to make a connecting rod. It shows here. In this connecting rod, there will be forming a connecting rod step 1 and step 2. So there are different steps that you can look at.
Connecting rod is manufactured by upsetting a cylindrical billet using closed impression dial. On the left hand side, the simulation describes step 1 of forming of a connecting rod with upper die in yellow, lower die in green, and a cylindrical billet sandwiched in between. On
So I won't go further down, further into this because shortage of time, and mostly it is just about listening. But there are, for example, fluid mechanics. You can actually play around and do experiments in that. So please go through all these, whatever you want, do it on your own and find out. If you have any questions, you can definitely write to us. If you want, we can even have a one-on-one meeting with anybody who is interested in something. But basically, any support that you would want, please, there is one support link at the bottom. Please write to that support link, and our support team will get back to you. Sorry, yeah, about all this. So, if you have any questions, I will take them, because as far as my virtual lab demo is concerned, if you want some other department, I can show you, but it is unending. See, as I said, this is more about helping you understand what is the architecture and what is the structure of the virtual lab portal, and how you can move around and how you can use it. Now, the later part of the webinar, or rather the outcome of the webinar, would be that there are feedback forms that are shared with you. And if you can download that feedback form, or even in the soft copy, in the Word copy, you can fill it up. And then at the bottom of that, there's one small table as to how you feel. What is the level of interest that you feel when you start the virtual lab, going through the virtual lab? After you have gone through 5 experiments, how you feel? After you've gone through 10 experiments, how you feel? And how do you feel after going through 15 experiments? Please fill that up. And in the main feedback form, please write the experiment name and the lab name. For example, data structures is the lab, or data structures 1 is the lab, or problem solving is a lab. Then in that, there will be multiple experiments. For example, in data structures, it was merge sort, it was heap sort, it was so many different experiments are there. Which are the ones that you looked at and which you feel? See, every experiment that you write, I'm not saying you should do it, browse it, but at least open the experiment and see what it is, whether it is relevant to you, and please write it. Like that, a minimum of 15 experiments you should see, and return the form. I have shared a link where the forms can be pushed into Google Drive. Please push them. And the number of experiments that you are actually browsing and listing out there, that is those are the number of usages that each student is giving. So this will contribute to CMR's overall commitment of giving usages. Okay, so that feedback form, and I have given the entire instructions to Professor Varaprasad, and he will share the form, he will share everything you can do online. I have a small request. If you can put your signature image where you're supposed to sign. See, all these forms, feedback forms, are proof for the MHRD to say that students have actually used it. So it's a mandatory document, the feedback form. In physical form, we used to actually get people to fill up with a pen and paper on the form and sign it. But now that we are not in a position to do that, my request is that please have an image of your signature with the date and paste it in that location where signature is there. Otherwise, at least please write your name signed by so and so, and write your put the date on it. Okay, so this is very important to help us as well as to help your nodal center also. So please go ahead and do this. And any questions you have, either you can put it in support. We will answer it. Somebody will answer it, or through Professor Varaprasad, you can contact me also if you need some specific help. For the faculty, what I need to say is, please look at all those experiments which are not in your which are there in your syllabus but not in virtual labs, which you think should be built by virtual labs. Please think about it whether you would like to actually get involved in building those experiments. So when you build an experiment, the structure roughly is that the subject matter expertise comes from the professor or the faculty who is involved in this. Then you have a team of 3 or 4 students. One student will know have an idea about IT, how to write code. The others will support him, or all of them could be people who know code, or whichever way. Since it's computer science, most of you, all your students would know how to write code. So then there is a procedure where you are going to give us for the subject matter expert, for the subject content, you're going to give what is the learning objective, what is going to be the procedure, what is going to be the theory, all that you're going to give. So there are 5 steps that we have in our procedure. We will follow that. But first, what you need to do is to give us on white paper a proposal, which will say what the experiment is, that it is there in your curriculum, and it is not there in virtual labs. So if the faculty can do that, it will be very good. So now any further questions I'm willing to take. I'm stopping to share, but I'll take questions if there's anything.
Okay, sir. Let's wind up the session since there are no questions.
Yeah, I think there are two questions which have come up on the
Yeah.
chat. Maybe you can ask them. No, don't worry about. Unmute yourself and ask the question.
Anybody have any questions? Yerra Abhiram Chaudhary. Do you have any question? Arnold Thompson something. You have any question?
No, sir.
Yeah. Okay. Okay, sir. We will wind up the session, sir.
Yeah, thank you.
Yeah.
Thank you all so much. Please use the virtual labs, benefit from it. Thank you so much. I'm leaving the.
Thank you, sir. Thank you, Ravi Shankar, sir. Thank you for sharing your virtual lab related information to our first year BTech students.
Thank you.
Thank you from CMR Technical Campus ESC department.
Right.
And at the same time, thank you, Shashank, sir, for joining with us. So thank you, students. So you will be having another session at 2 o'clock in the afternoon. You will be getting the links soon. Please be regular. Okay. Hope everybody have filled the form that I have posted in the chat. Thank you, everyone. Thank you, sir.